Hello and welcome to Astronomy Daily. I'm Anna.
And I'm Avery. And our producer has handed us quite a lineup today.
He really has. NASA just rewrote the future of human spaceflight, not once, but twice in a single day.
We're talking a $20 billion moon base, the first nuclear-powered spacecraft heading to Mars, a star system that looks just like our own solar system did 4 billion years ago.
Plus, a brand new look at one of the most iconic objects in the night sky, a clever technology that could protect future moonwalkers, and a rocket company celebrating another milestone launch.
It's Wednesday, the 25th of March, 2026. This is Astronomy Daily.
We start with what is genuinely a landmark moment in the history of space exploration policy. NASA has officially canceled, or rather paused, the Lunar Gateway program.
For anyone who needs a quick refresher, the Lunar Gateway was a planned space station that would have orbited the moon. The idea was that astronauts aboard the Orion spacecraft would dock with Gateway before descending to the lunar surface. It's been in development for years, with major contractors like Northrop Grumman already deep into building it.
And now, NASA's new administrator, Jared Isaacman, who took the top job back in December, has announced they're shelving it. The announcement came on Tuesday at what NASA called its Ignition Day event at headquarters in Washington.
And it wasn't exactly a shock to those following the program closely. Isaacman's exact words were, "It should not really surprise anyone that we are pausing Gateway in its current form and focusing on infrastructure that supports sustained operations on the lunar surface."
So instead of an orbital station, NASA is going all in on building an actual base on the moon. The plan comes with a $20 billion price tag over 7 years, and it's structured in 3 phases.
Phase 1, running from 2026 to 2028, is described as getting to the moon reliably. That means ramping up robotic lander missions, testing technologies, and scouting potential base locations at the lunar South Pole.
Phase 2, from 2029 through 2031, starts physically building the base. Communications, navigation, power infrastructure, larger cargo landers, and the goal of 2 crewed missions per year. Japan's space agency, JAXA, is contributing a pressurized rover for this phase.
And Phase 3, from 2032 onwards, is when it all comes together. Long-duration human presence on the lunar surface with multi-purpose habitats from the Italian Space Agency and a lunar utility vehicle from the Canadian Space Agency.
What about the Gateway hardware that's already been built? That's not going to waste. NASA says it will repurpose components for the moon base and for other programs, including, as we'll hear shortly, a very exciting Mars mission.
There are political dimensions here too. Isaacman was direct about the competitive pressure from China, whose space program is targeting a lunar landing by 2030. He said, and I'm quoting, "We find ourselves with a real geopolitical rival, challenging American leadership in the high ground of space."
NASA also confirmed it intends to land astronauts on the moon before the end of President Trump's term, with Artemis 4 and 5 targeting the lunar surface as early as 2028.
Now, the international partners who had committed to the Gateway are understandably going to have questions. This is a significant reshaping of an agreement that involved space agencies around the world.
Absolutely. But the message from NASA seems to be the destination hasn't changed. It's just how we get there that's being reimagined, a permanent base rather than a way station in orbit.
It's a bold, ambitious pivot. Whether the timeline proves realistic, that's the big question.
But wait, that wasn't the end of the big announcements, was it?
Certainly not. And that segues perfectly into our second story, which was also announced at the same Ignition Day event. And honestly, it might be even more mind-bending.
NASA is planning to launch the world's first nuclear-powered interplanetary spacecraft in December 2028. It's called Space Reactor 1 Freedom, or SR-1 Freedom for short.
Let's just sit with that for a second. The first nuclear-powered craft ever to leave Earth's sphere of influence. We've had nuclear-powered surface rovers and probes using radioactive decay for power, but this is different. This is a fission reactor propelling a spacecraft to another planet.
The technology is called nuclear electric propulsion, or NEP. Rather than using the reactor's heat directly for thrust, as a nuclear thermal propulsion would, NEP uses a fission reactor to generate electricity, which then powers highly efficient ion thrusters. It's described as extraordinarily efficient for moving large amounts of cargo across deep space.
And SR-1 Freedom will actually be built partly from repurposed Lunar Gateway hardware, specifically the power and propulsion element that was already under development, so nothing is going to waste.
The spacecraft will carry a payload called Skyfall, a fleet of 3 small helicopters modeled on NASA's Ingenuity, the famous rotorcraft that flew 72 times on Mars after arriving with the Perseverance rover.
These Skyfall helicopters will be deployed mid-air during Mars atmospheric entry, no sky crane required, and will land themselves on the Martian surface. Their mission? To scout potential future human landing sites, map hazards, and use ground-penetrating radar to locate subsurface water ice deposits.
That last point is crucial. If we're going to put humans on Mars, which is clearly the long-term ambition, knowing exactly where the water is, how deep it is, and how accessible it might be for in-situ resource utilization is absolutely foundational.
NASA's program executive Steve Sinecor also left a door open for SR-1 Freedom to continue flying after it drops off the Skyfall payload. Whether it heads deeper into the solar system is still an open question.
And there's a broader strategic logic here. SR-1 Freedom isn't just a Mars mission, it's a pathfinder. The plan is that what we learn from it will inform Lunar Reactor 1, a future fission power system for the moon base. The same nuclear technology that will power the moon base could one day power missions to the outer solar system.
Not everyone is convinced the 2028 timeline is achievable. Some prominent voices in the planetary science community have been skeptical. The timeline is extraordinarily tight for a first-of-its-kind nuclear spacecraft, but the ambition is undeniable.
For me, the exciting thing is that this mission was conceived to also do real science. NASA's science chief, Nicola Fox, made the point that SR-1 Freedom is a great opportunity to carry science instruments to Mars, and researchers are being invited to propose what instruments could fly.
Nuclear propulsion, Mars helicopters, water ice mapping. This is the space program firing on all cylinders.
Let's travel 437 light-years away now to the constellation Aquila, where astronomers have made a discovery that is genuinely remarkable, a time capsule of what our own solar system may have looked like over 4 billion years ago.
Using the European Southern Observatory's Very Large Telescope in Chile, researchers have directly observed 2 planets in the process of forming around a baby star called PDS-70. And I mean baby. This star is only around 5.4 million years old. Our Sun is about 4.6 billion years old. So we're talking about a system that is barely a toddler in cosmic terms.
The 2 planets, designated Wispit 2b and Wispit 2c, are both gas giants, more massive than Jupiter. And crucially, they're actively carving out gaps in the disk of gas and dust that surrounds their parent star. That's actually how astronomers spotted them, by the telltale lanes they're clearing in what's called the protoplanetary disk.
Wispit 2b sits at about 60 times the distance between Earth and the Sun. Wispit 2c is closer in, at around 15 Earth-Sun distances, so about 4 times closer to the star than its sibling.
The team used multiple cutting-edge instruments to confirm the discovery, including SPHERE and Gravity Plus on the VLT, and the lead researcher, Chloe Lawler from the University of Galway in Ireland, called Wispit 2 the best look into our own past that we have to date.
There's also hints in the disk structure of potentially a third forming planet, possibly of Saturn's mass. The researchers think there may be more worlds yet to be detected.
What makes this so significant isn't just that we've found planets forming, we've seen evidence of that before, but that we can directly image them at this early stage with this level of detail. It's like watching a solar system being assembled in real time.
And the comparison to our own system is striking. Two large gas giants forming at the outer edges, potentially more planets inward. It does rhyme with the architecture of our own Jupiter, Saturn, and the rest.
The research was published this week in the Astrophysical Journal Letters, and I think we can expect a lot more observations of WISPIT 2 in the coming years, including potentially with JWST.
Now we have a story that is equal parts science and nostalgia. NASA has released stunning new Hubble Space Telescope images of the Crab Nebula, and they were taken exactly 25 years after Hubble first pointed at this iconic object.
For those new to the Crab Nebula, it's the remnant of a supernova explosion that was observed from Earth in the year 1054. Chinese and Arab astronomers at the time recorded a new star so bright it was visible in daylight for weeks. What we're looking at today is the expanding wreckage of that explosion, a roiling cloud of gas and dust about 6,500 light years away in the constellation Taurus.
It's one of the most studied objects in the entire sky, and Hubble has been watching it for a quarter of a century. The new images reveal something beautiful and slightly eerie. You can actually see the nebula changing. The cloud is still expanding, still in motion, nearly 1,000 years after the original explosion.
Astronomer William Blair from Johns Hopkins University, who was involved in the study, put it beautifully. He said, "We tend to think of the sky as unchanging, immutable. However, with the longevity of the Hubble Space Telescope, even an object like the Crab Nebula is revealed to be in motion, still expanding from the explosion nearly a millennium ago."
What I love about this story is that it's a reminder of just how extraordinary Hubble's lifespan has been. This telescope launched in 1990. It has now been watching the sky, watching the Crab Nebula specifically, for 25 years. The ability to compare images over that timescale and actually see change is something no single astronomer's career could deliver.
The new images are published in the Astrophysical Journal, and they are, frankly, gorgeous. All those blues and golds and reds, the intricate filaments of the shell, the pulsar at the heart of it all still spinning away. If you haven't seen them, do look them up.
The Crab Nebula, still expanding, still spectacular, still teaching us things after nearly a millennium.
Here's a story that combines elegant simplicity with genuinely important science. Researchers from Los Alamos National Laboratory have published 2 new studies suggesting that fiber optic cables laid directly on the surface of the moon could be used to detect moonquakes.
Now on Earth, fiber optic cables used for sensing have to be buried, because even a gentle breeze can vibrate the cables and create noise in the data. But the moon has virtually no atmosphere, there's no wind, and it turns out that means you don't need to bury them at all.
The technique is called distributed acoustic sensing, or DAS. Essentially, you send rapid laser pulses through a fiber optic cable, and tiny imperfections in the glass scatter light back to a detector. By analyzing those reflections, you can measure vibrations along the entire length of the cable, which means a single fiber could function like thousands of individual sensors at once.
Compare that to what we had during Apollo. 5 seismometers placed at specific points on the near side of the moon between 1969 and 1977. Incredibly valuable data, but enormously limited in coverage. A fiber optic network could cover hundreds of kilometers of the lunar surface with a rover simply unspooling cable as it drives.
And moonquakes are a fascinating phenomenon in their own right. Unlike earthquakes, which are driven by tectonic plate movement, moonquakes are caused by tidal forces from Earth's gravity, meteorite impacts, and extreme temperature swings. The lunar surface swings from over 100 degrees Celsius during the day to minus 170 degrees at night. And because the moon is geologically quieter in some ways, seismic energy doesn't dissipate as quickly. A moonquake can ring on for much longer than an equivalent event on Earth.
Researchers also pointed out that fiber networks could monitor hazards beyond moonquakes. When a rocket lands or takes off the moon, particles get blasted off the surface at up to 2 kilometers per second. For future bases and infrastructure, understanding how far that debris travels is genuinely important for safety planning.
Lead researcher Carly Donahue from Los Alamos summed it up. Fiber optic cables are lightweight, robust, and inexpensive. In the world of space exploration, where every kilogram to the lunar surface costs a fortune, that combination is extremely attractive.
A small, elegant solution with big implications for how we understand and operate on the moon. We love a story like that.
There's certainly no shortage of moon planning stories around at the moment.
And we close today with a launch story, one that's about much more than just putting 2 small satellites into orbit.
Rocket Lab launched 2 pioneering navigation satellites for the European Space Agency this morning in a mission called Daughter of the Stars. The Electron rocket lifted off from Rocket Lab's complex on the Mahia Peninsula in New Zealand, targeting a circular orbit 510 kilometers above Earth.
The 2 satellites are the first of an eventual 11-satellite demonstration constellation called Celeste. And Celeste itself is the first ever satellite navigation initiative that Europe has launched into low Earth orbit.
Most people will be familiar with Galileo, Europe's answer to GPS, which operates from medium Earth orbit several thousand kilometers up. Celeste is something different. The idea is to add a complementary low Earth orbit layer that flies much closer to Earth, enhancing Galileo's performance. Stronger signals, faster time to fix, better resilience against jamming and spoofing.
There's also a geopolitical dimension here. The Baltic Sea region has seen significant GPS jamming and spoofing incidents in recent years. LEO navigation satellites broadcast stronger signals across multiple frequency bands, which makes them far harder to interfere with.
Now, the mission name Daughter of the Stars is absolutely beautiful, and it's not a coincidence. Celeste is named after Maria Celeste, the daughter of Galileo Galilei, the 17th century astronomer, whose name already graces Europe's main navigation constellation. There's a lovely continuity there.
This is also the first ever dedicated Rocket Lab mission for the European Space Agency, and Rocket Lab has been having a remarkable year. Their Electron rocket is becoming one of the most reliable small launch vehicles on the planet. And missions like this show just how far New Zealand's space industry has come.
There was actually a practical urgency behind this launch. ESA had a deadline at the International Telecommunication Union. They needed to put their allocated frequency bands into operation by May 2026 to secure them for the future operational system. The launch today wasn't just scientifically significant, it was technically necessary.
ESA hopes to have the full 11-satellite demonstration constellation operational by 2027, with a much larger operational system to follow. 300 satellites in orbit by 2035 is the eventual target.
From a hilltop launch site in New Zealand, Europe takes its first steps towards its own low-orbit navigation network. Rocket Lab, as always, getting it done.
Rocket Lab is fast becoming the little company that could. Congratulations all round on today's successful launch.
And that is our show for Wednesday, the 25th of March. What a day it's been for space news.
NASA reimagining its entire lunar architecture, the first nuclear interplanetary spacecraft on the drawing board. Planets forming around the baby star 437 light years away. Hubble still delivering awe after 35 years in orbit. Fiber optic cables on the moon, and Rocket Lab heading to 510 kilometers above Earth for ESA.
If you enjoyed today's episode, please subscribe, leave us a review, and share it with someone who loves space as much as we do. You can find us at astronomydaily.io and across social media as @AstroDailyPod.
We're on X, Instagram, TikTok, Facebook, and Tumblr. Come find us wherever you prefer to hang out online.
This is Astronomy Daily. Keep looking up.
And we'll see you tomorrow.
Astronomy.